between?
The Malacoma doors.
Flight dynamics team is the one who best know where the spacecraft is at each specific time.
Within ESA, flight dynamics is considered a bit of a black box simply because the scientists, they put requests in, and the flight control team gets commands out, and then the spacecraft ends up doing what it's supposed to do. And nobody really understands why except for us.
There is a steep learning curve once you join ESA. There are a lot of things you do not learn at university. We are often confronted with small mathematical problems that we need to solve.
We don't have to react immediately, yeah, but let's say quite quickly, and we have to have some quite fast turnaround. But the main reason for that is that we want to resume the science. Yeah, the science time is a valuable time.
We have the command subsystem, which generates commands which we send to the spacecraft to perform orbit correction maneuvers to get the spacecraft where it's supposed to go. Finds out where a spacecraft is at any given time. Figures out how we get the spacecraft where it needs to be. Monitors that the spacecraft actually does what it's supposed to do. Rosetta is arriving at a comet mid-2014. And we have to prepare for that. I mean, this is not something that the European Space Agency has ever done. Go up to a small body like a comet, fly around the comet, and choose a spot where we want to deliver the lander, then maneuver the spacecraft so that to eject the lander to that spot. My team checks that everything that the command subsystem and the attitude monitoring subsystems do, that all that is done correctly.
I divide my time between development and operations. So if there is any operations to be done on that day, if there is a maneuver to be prepared, then I would dedicate most of the day to these operations, because this usually takes priority. And then you need to start moving from your office to the flight dynamics room to talk to the rest of the team to see which is the status until everything is finished. Some of the days I'm concentrated on the development, so because we also have to prepare for future missions. And in those days I might stay in my office the whole day, quiet and concentrated in one specific task.
I'm a mathematician, so I was interested in space, so what are you going to do? So I applied, and I got invited for an interview. I came here and it sounded interesting, and then I joined, and the more I learned about flight dynamics, the more I found it fascinating. This is why I'm still here 7 years later. Yeah? So this is not something a mathematician knows what it is, usually.
My section is responsible for validating and testing all the data products that are used in operations sent to the spacecraft, sent to the scientists, in order to avoid any harm to the mission. So we start long before a mission is launched, typically 2 to 3 years before a mission is launched. We start developing our approach, how we want to build up the test and validation system for that mission. Then we develop the tools in-house for this support. And the last 6 to 9 months before a mission, we have intensive test campaigns. The highlight then is, of course, the launch and the early phase of the mission, where we online in real time check the data products that are sent later to the spacecraft or to other members of the ground system.
Yes, we did. So I work only with missions which are orbiting the Earth or around the Earth and looking at our planet. And inside my section, I'm part of the attitude monitoring and command generation team. And this means I'm, with the rest of my team, of course, we are responsible of getting some part of the data that it's generated in the spacecraft. We have to get it and analyze it and try to see if the spacecraft is pointing in the right direction and there's no any misperformance.
So I'm in charge of doing orbit determination for mainly interplanetary missions. Navigating an interplanetary probe is much more difficult. It's, let's say, especially when you want to insert it to a planet like we did for Mars Express and Venus Express, or a small solar system body like a comet for Rosetta. I mean, these are very challenging navigation tasks. Starting from this heritage from Giotto, which was a small software, let's say, we built something which we can use for the future, which is now called the Interplanetary Software Facility for navigation of interplanetary spacecraft.
Especially flight dynamics is very, to me, is very interesting because you have the full range of things that you do. So you go in and study up in the spacecraft. Yeah, you learn how the spacecraft. We actually get a user manual for the spacecraft. So we have a user manual. We read the user manual. You figure out what the spacecraft does, what it can do, and then we use that information to plan how we're going to do what the scientists want us to do, basically.
Okay, thank you very much. Yes, but I need to go to the next.
We are really a team of experts where this knowledge is transferred to the next generation.